This is the next chapter that we're going to be doing, and we'll be doing a few different types of tests in upcoming chapter as well. It's really honestly where you do, it's a glorified z-score, or then you use the chart and find the probability from it. And sometimes you got to find the greater than, so you have to subtract from 1. And if you're doing means, the second day or the second lesson that we're going to be doing is kind of like your t-value or t-score, because it's going to work the same way. We have z is going to work with the proportions, and t is going to be working with the means. The idea of it is to examine evidence in favor of a claim about the population from which the sample is drawn. So you're going to look at materials or calculate something and see if there's anything that helps you support your claim good enough, or about the actual population that it comes from. It's the same type of thing that we do with the confidence interval. It's just another way to check data and to see if something is plausible or not. And you're trying to decide if something has a chance of occurring, like an actual chance of it occurring. And what we're going to be doing is we're going to be using alpha and testing it around the 5% mark, meaning that if you get that something occurs less than 5% of the time, we're going to say that it's probably something that, is not plausible to happen. So less than it can probably not occur by chance. And that's the key thing here, is this 5% and seeing where it is. Sometimes we'll say alpha is 1% because we're being really, really strict about it, and we want to make sure that, it's really not plausible for this to happen by chance. If the problem doesn't state it at all, we're going to be using 5%. Pretty much, if it happens below that amount, then it probably can't possibly happen by chance. A couple of questions that have arisen is we're going to be calling HO is equal to the null hypothesis. And we're going to state these when we're solving our significance test. This is what we are testing to be true. And there's going to be an HA, which is the alternative hypothesis. And we're going to say that this is something basically like, what's the alternative? For example, for number 1. we're not going to actually do it. I just want to figure out and show you how you can figure out what the null hypothesis is, what the alternative hypothesis is. For example, in the article, and I have to give you a lot of information to be able to solve it, 7 million U.S. teens would flunk treadmill tests. This article summarized the results of a study in which 2,205 adolescents took a treadmill test. I left off some other information about the ages and stuff like that about the students, just because I wanted to get to the meat and potatoes of this problem. Of the 2,205 tested, 750 showed a low level of fitness. Does this sample provide support for the claim that more than 30% of adolescents have a low level of fitness? So our very first thing normally is to state what our null hypothesis is and what our alternative hypothesis is. So we want to decide from this, what do we think the population look like? The null hypothesis is going to be, what measure did it say that we're supposed to be around? Or what measure actually did it say, does this sample provide support for the claim that more than 30%? In this problem, our null hypothesis, we always want to put like the one value. What is our hypothesized value in this spot? And then look at the problem and see what's the alternative, or what's the part that we're trying to see as the alternative. And in here, the word more than 30%. So maybe the true proportion is more than 30%. So usually these numbers are equal because we're going to calculate this only one time to figure it out. Now, when we measure this, keep in mind, we're going to be doing a z-score, and we're going to see where 30% lies and where the probability is, but we want to test more than. So our number that we want is going to be the top tail over here. So whatever answer we get, we're going to have to do 1 minus the answer to get the actual probability, to test it, to get our what we call a p-value. P-value is what we're going to compare to our alpha. And since this problem said nothing about alpha, we're going to compare it to this and see about 5% or not. So I just want to see if we can set up the alternative hypothesis and the null hypothesis. So I'm going to try another one too. So when I read this one, it says the report of California's education skills gap, modest improvements could yield big gains, states nationwide 61% of high school graduates go on to attend college the year after graduation. College going rate for high school graduation in California was estimated at 55% from a random sample of 1,500 people. Can we conclude that the proportion of high school graduates in California differ from the national figure? So when we're looking at this problem, the big idea is trying to figure out what number are we going to use, 61% or 55? I'm going to start on the next page and put my null hypothesis and set up my alternative hypothesis. And I'm trying to estimate the population. So when I look at something like this, what do I think is representing the population of all? I would say nationwide, 61% of high school graduates go on to attend college. So I would put in here 0.61. If you look at the rest of the question, there's no more than like the last one. There's no less than like the last one. It says, can we conclude that the proportion of high school graduates in California differ from the national figure? So if the national figure is 0.61, differing from the national figure would be not equaling 0.61. And that's the difference between these there are two type of ways to set this up, where you have, like the last example, the upper tail, like this example, which is going to be not equal to 0.61. You're going to be testing 0.61 and finding the probability of being in either tail of this, because not equal would mean lower than or greater than. and we're going to be comparing it against 0.05 or 5%, unless otherwise noted.